we completed process P3. So after completing process P3, work was updated 743. Now check for the next process in the table, that is process P4. After P3, process P4 is there. Write the need of process P4. So the process P4 need is 4, 3, 1, and the updated work is 7, 4, 3. Okay, 4 is less than 7, 3 is less than 4, 1 is less than 3. So it is meeting the condition, that is x less than or y then. Okay, less than y then. Okay, so in such condition what you need to do? So finish off. Which process I choose? Process P4 is true. So if it is true, according to algorithm, what you need to do? You need to update the available, that is work 743, okay, to new one. So 743 is updated with the allocation of process P4. P4 allocation is how much? 0, 0, 2. It is given in the question itself. 0, 0, 2. Addition this one, you are going to get 5, 4, 7. Okay. So new work is 7, 4, 5. Continue with the next process. So here actually all the process completed. P4 also completed. But in the initial itself, P0 was failed, right? Again, the process P2 also failed. So you can give chance in the next round now. After completing P4, come back to the process P0. Okay, circular way. So coming to process P0, the need of process P0 is 743. 7, 4, 3. And the new work available is 7, 4, 5. Okay, check the condition. 7 is not less but it is equal. 4 is not less but it is equal. 3 is less than 5. So it is actually meeting the condition. You can finish what? Process P0 also. It didn't even finish in the beginning itself. Okay, but the resources are available now. So now you can give chance for the process P0. In the initial stage, it was not finished because of the shortage of the resources. Okay, it is true. Finish of process P0 is true. Okay, update this work 745 with the allocation of process P0, that is 010. So 010. So you are going to get 5, 5, 7. New work is 7, 5, 5. So go to the table again and check if any other process left out. Process P0 just now we completed. P1 we completed in the beginning itself. The only process left out was the process P2. So check the need of the process P2. It is having 6, 0 and 0. And the work available is 7, 5, 5. So it is actually less. 6 is less than 7, 0 is less than 5, 0 is less than 5. Okay, so you can actually finish off this process also. So finish process P0 is equal to true. So then what you need to do? Work should be 755 plus the allocation of process P2 is how much? That is 302. Okay, 302. That will be 7, 5, 10. So work is 10, 5, 7. Work is nothing but what? It is a resources, right? So it is not the end of a question, means a solution. So you need to write the safe sequence. Okay, so safe sequence means the process which completed in the first. So we finished process P1 first. Okay, so write the process P1. Next completed process is process, that is P3. Write that. Next completed process is P4. And next we completed process P0. And at the end we completed process P2. This is actually your answer. Okay, you can write yes, system is in safe state. And the safe sequence is P1, P3, P4, P0, P2. Okay, this is your answer. And you can cross verify the last resource you updated 1057, that should be matching with the resource given in the question 1057. Okay, so it gives you the clarity that problem is correct. Okay, so that is about the Banker's algorithm, bit lengthy but it's easy. So you can just look at the problem here. I calculated need matrix first, okay, and then I started with the algorithm for the safe sequence. I initialized work is equal to available. It is initially 332. I started checking for the processes whether it is finished or not finished. So I assumed initially all the processes are not finished. Okay, while checking I came to know that process P0 is not meeting the x less than or equal to y condition. So I rejected process P0 and I move forward to the process P1 need table. So when I checked it, so I got the true, that is condition was meeting. So that is why I made process P1 to a finished stage, that is true. And I updated the available 332 with the allocation of the process P1 200 and I got new work 532. So by keeping new value 532, I look forwarded for the next process who has not completed the task. So I found out process P2 need which is not meeting the condition. So I rejected process P2. I moved on and I got a process P3 and it was meeting the condition, that is the need is less than the available. So I made it true and I collected back the allocated resources. Okay, so that is 211. Allocation of the process P3 was made addition with the available resources and I got a new value 743. And by keeping this 743, I again continued for the next process in the table. So I got process P4 meeting the condition. So again I repeated the procedure 743, the old available work, that is work is available, same work and available are same. So I updated with the allocation of process P4. When you find out that the process is going to be true, it is going to be finished, then you can collect back the resources allocated previously, that is allocation. So you are going to get 745. And again I came back to the circular way. So I found out process P0 now we can finish. Initially you couldn't able to finish. Why? Because initially the resources was only 332. Now the resources was updated to 745. Okay, so now he can actually complete the task. So he completed. So again moved forward. So P2 also completed the task. At the end, so I got the 1057 which was matching with the question part, that is 1057. Okay, the meaning is system executed, okay, in a safe way without any deadlock. I avoided a deadlock using this algorithm. Okay, if I'm going to allocate the process P0 only, okay, in the initial stage itself, if I am going to allocate the process P0 means the all system will be in a deadlock state. Okay, so I just preempted this process P0, not using the resources. That's it. And then again I did same thing for process P2. Okay, so that is about the Banker's algorithm first problem.